In this video, we are going to talk about solving absolute value inequalities. So we are going to take what we learned about solving inequalities and then what we learned last unit about solving absolute value equations and kind of put those two ideas together in this lesson. So we have two different types of inequalities. We have less than and we have greater than. So we're going to first look at less than, okay? And I've got some steps for you and I've got a graph to kind of talk you through why this process works the way it does. Okay, so we're first going to look at less than inequalities. So the first step is to isolate the absolute value. Okay, so this was the first step when we were solving, okay, absolute value equations. So when dealing with inequalities, that first step is consistent. Okay, we got to get the absolute value part by itself. Okay, and we did that in this example right here that I have for you. Okay, and notice that's what I have graphed over here. Okay, so the absolute value of x plus 2 is the red graph that exists over here. And then we're looking for when is that less than 3. Okay, so let's first talk about absolute value. Okay, so I think about values that are less than 3. Okay, it is the values, okay, between 0 and 3. Okay, so x plus 2, okay, whatever this is, as long as that is less than 3, okay, my statement is true. So the way the absolute value works is, remember, it makes whatever's inside it positive. So whatever values I plug in for x, I need that statement to be between either 0 and 3 or between 0 and negative 3, okay? Because if x plus 2, right, if that whole thing equaled, let's say, not highlighter, if that whole thing equaled negative 2, okay, what is the absolute value of negative 2? Positive 2. Is positive 2 less than 3? Yes. Okay. Same thing, say like if I had x plus 2 equaled 1, okay? The absolute value of 1 is 1, okay, because the absolute value of any positive number is just itself, okay? Because we can, again, think about absolute value as distance from 0, so the distance from 0 is 1. So 1 is less than 3, okay, so that also works out. So these values, okay, that are between negative 3 and 3, okay, so as long as x plus 2 is between negative 3 and 3, okay, we're good to go. All right, so that is how we set up this next step right here. Okay, so our second step, once we've isolated the absolute value, is to take whatever is inside the absolute Take whatever is inside the absolute value bar. So in this case, it's x plus 2. Okay, set it between that number and the negative of that number. Okay, so when I say between, that means I'm writing an and, okay, compound inequality. Okay, because remember, again, this is saying that x plus 2 is greater than negative 3 and x plus 2 is less than 3. So we're looking for the set of values that make both of those statements true. Okay, because we've got to fall between the negative 3 and 3. Okay, and then from there you can just solve for x, and that gives you your possible x values. Okay, so when I subtract 2 from both negative 3 and 3, I get x is between negative 5 and 1. Okay, and notice, if I look on my number line, between negative 5 and 1, okay, those are the values. Okay, here is negative 5. Okay, here is 1. Okay, those are the values where my function, notice, is less than that y value at 3. So this is the line y equals 3. Okay, and I'm looking for when is my absolute value function less than that. Okay, so it is this whole part of my graph right here. Okay, and that part of my graph exists when my x values are between negative 5 and 1. Okay, so that's kind of how the math connects to the graph. Okay, now we are not going to graph absolute value equations. Okay, or inequalities, we're just going to solve them. Okay, but I wanted you guys to kind of have a picture so you could hopefully see what was going on here. All right, so again, we're taking what we learned about absolute value and what we learned about compound inequalities to help us solve these. Okay, so let's do some examples together. All right, so step 1 is to isolate the absolute value. So to do that, I need to subtract 20. Okay, I need to get the absolute value bars by themselves. Okay, so if I subtract 20, I'm going to have -3, the absolute value of 5x minus 2, okay, is greater than or equal to -19 minus 20 is going to give me -39. Okay. Now, guys, notice this is -3 times the absolute value of 5x minus 2. Okay, so the opposite of multiplication is division. So to get the absolute value bars by themselves, I can divide both sides by -3. Okay, when I do that, I'm going to be left with the absolute value of 5x minus 2. Again, when I divide here, remember I'm dividing by a negative number, so this inequality symbol flips. Okay, negative divided by a negative becomes positive. 39 divided by 3 is going to give me 13. Okay, when I go to solve this, okay, 5x minus 2, I've got to be between 13 and -13. Okay, because remember, if the absolute value is less than 13, that means I'm between 0 and 13. Okay, but then if I think about on the opposite side, I could also be like the inside of the absolute value could equal like -11. Okay, because the absolute value of -11 would be +11. Okay, which is less than 13. So we are going to bracket ourselves between -13 and 13. Okay, and then I'm going to solve by adding 2 everywhere. When I do that, I get -11 is less than or equal to 5x is less than or equal to 15. Okay. Then I'm going to divide both sides by 5. Okay. That gets me x by itself. Okay, x is less than or equal to 3, and then x is less than or equal to, we're going to leave this as a fraction, guys, -11/5. I'll tell you right now, a lot of the times when we do these problems, okay, we're going to end up with one fraction as part of our answer. It's just kind of how it goes, all right? So don't let the fractions scare you, okay? So that is the answer for this one, okay? If I think about what that looks like on the number line, okay, we'll say -11/5 is here. We'll say 3 is here. Okay, again, I'm going to have closed circles at each of these, and I'm existing in this space between the two. Okay, so my final answer in interval notation will be the bracket. And that is my final answer in interval notation. Okay, so that one had a lot of steps to it in the solution process. Okay, but hopefully everything feels a little familiar, okay, from everything we've done so far. Okay, let's look at number 2. Okay, I want you to take a second. I want you to isolate the absolute value bars by themselves. So isolate the absolute value part of this inequality. All right, so the first step to do that would be to add 15 to both sides. So when I do that, I get that -9 plus 15 is going to give me a +6. Okay, again, this is 3 times the absolute value. So to get the absolute value part by itself, I'm going to divide both sides by 3. I'm going to get the absolute value of 2x plus 6 is less than 2. Okay, which I'm going to turn into this. Okay, so that is my step 1 into my step 2. Okay, and now I'm going to solve this compound inequality by subtracting 6 on both sides. Okay, when I do that, I get -8 is less than 2x less than 2 minus 6 is -4. Okay, divide both sides by 2. I get -4 is less than x, which is less than -2. So if I think about my number line, okay, I've got a -4 and a -2, okay. Both of these are going to have open circles, okay, and then I'm existing in the space between the two, okay. So my final answer is going to be -4 to -2, okay. Both get parentheses, okay. The one thing about solving absolute value inequalities is the notation is going to be consistent throughout the problem. So like here, we had a less than, we had a less than here. So then we have a less than here and a less than here, okay. Same thing here, we had a less than or equal to, so we have a less than or equal to and a less than or equal to, okay. So our symbols stay consistent. Okay, so I want you guys to try this one on your own, okay? So isolate the absolute value part and then set up your inequality once you drop the absolute value bars, then graph on a number line and write your final answer in interval notation. Okay, so to isolate the absolute value, I had to add 7 to both sides. So when I do that, I get the absolute value of x minus 2 is less than 5. Okay, again, my inequality symbol that is here is the inequality symbol that I write in my step 2. Okay, so I've got x minus 2 is between -5 and 5. To get x by itself, I need to add 2 to both sides. Okay, so then I get x is between -3 and 7. Okay, and again, the -3 and 7 get parentheses because I'm not equal to those values. I'm just close to them. Okay, so my final answer is parentheses -3, comma 7, close parentheses. Okay, so that is solving less than absolute value inequality. So now we're going to do greater than, okay? Same kind of idea holds true. So when I think about my number line, okay, let's say 0 is here, let's say 3 is here, and let's say -3 is here, okay? I want to be greater than 3, okay? So I want to exist in this portion of my number line. Okay, and again, because I'm looking at absolute value, okay, I could also exist in this portion of my number line, all right? Because, for example, say I have -7, okay? Say that this portion, okay, x plus 2 equaled -7. So if that was true, okay, the absolute value of -7 is 7. Okay, 7 is greater than 3, that checks out. Same thing over here. Let's say I have 5, okay. The absolute value of 5 is just 5. Okay, 5 is greater than 3, that also checks out. Okay, so we're looking here for either existing below -3 or above 3. Okay, so we're falling outside -3 and 3. So this is going to be an or, okay, compound inequality. Oh, I meant to use my highlighter, not my pen there. So this is an or situation, okay? So one of these has to be true, okay? So when I set this up, okay, I take whatever's inside my absolute value bars, I keep it greater than my number, okay? And then I also make it less than the negative of that number, okay? So I have to flip, and when I flip, I make that value negative, okay? Then I solve each of those pieces, and notice my final answer that I get here is that x is less than -5 or greater than 1. Okay, so if I think about what that looks like on my number line, okay, it's this portion of my graph, and it's also this portion of my graph, okay, because again, this is -5. Okay, and this is 1. Okay. And I'm looking for when are those values, okay? When is my graph have a y value greater than 3? Okay, when is my absolute value of x plus 2 greater than 3? Okay, and that is when I have x values less than -5, and also when I have x values greater than 1. Okay, so again, that is kind of the connection to the graph. So one thing, because people are always kind of struggled the most with this, is when to do which. Okay, so they'll see this problem and they know, okay, I have to do something here where I have two inequalities, but they get stuck and can't remember which ones are which. Okay, my trick is to literally just think this in your head. Great or. And that's a crazy looking or. Okay, so instead of think or, great or. Okay, and that tells you you're writing an or compound inequality. Not the most advanced, way to remember, but that is something that I had students find helpful in the past. Okay, so let's do some examples. So for this one, again, process stays the same. We're going to isolate the absolute value. So I'm going to subtract 4 from both sides. Okay. Then I've got negative 4 times the absolute value of 1 minus x is less than negative 16. Okay. Again, I'm going to divide both sides here by negative 4. Okay. When I do that, I have to flip my inequality symbol. So I get the absolute value of 1 minus x is greater than 4. Okay. And I'm going to bring this back over here. So I have now isolated it. Okay. And again, I've got an absolute value is greater or than 4. So I'm going to take 1 minus x. I'm going to keep it the same. Okay. And then I'm going to write the word or, and then I'm going to write 1 minus x. I'm going to flip my inequality symbol, and I'm going to make that number negative. Okay. Now, when I solve for x here, notice I can do the same thing across both equations. So I'll work both of these at the same time, kind of like how I did it when I was solving absolute value equations. Okay. So this is a positive 1 minus x. So this is a positive 1 that I need to move to the other side. So I'm going to subtract 1. And again, I work across both equations. Okay. I like doing that. If you want to do one fully by itself and then do the other one, go for it. Totally perfect. Personal preference, up to you. So this becomes negative x is greater than 4 minus 1 is 3. Okay. Negative x is less than negative 4 minus 1 is negative 5. Okay. I need to divide both sides by negative 1. Okay. When I do that, I need to flip my inequality symbols. So I get x is less than negative 3, and I get x is greater than 5. Okay. So when I do this, I treat this exactly like I would have when I had my compound inequality. So I'm going to come to my number line. I'm going to mark my negative infinity and infinity. My negative 3 is going to be first on my number line, then my 5. Okay. If I'm less than 3, okay, I've got an open circle at 3, and I'm going this way. Okay. If I'm greater than 5, I've got an open circle at 5, and I'm going this way. Okay. So again, because it's an or, it's where either one of them exists. So anywhere that is covered, okay, is part of my answer. So my answer is going to be negative infinity, comma, negative 3. Again, I've got a jump here. So this is going to be my union. 5 to infinity. And that is my answer for this one. Okay. Because again, I'm existing anywhere either that orange or that purple inequalities exist on my number line. Okay. So let's try 2 more. Okay. So I want you guys to isolate this one by yourself. So your first step should have been subtracting 9. Okay. So when I subtract 9 here, I get 45 minus 9 is going to give me 36. Okay. Then I'm going to divide both sides by 6. I get x plus 2 is greater than or equal to 6. So that is absolute value bar isolated. Okay, and again, it's a great or. So I've got x plus 2 greater than or equal to 6. Or I've got x plus 2. I'm going to flip my inequality symbol, and I'm going to make my number negative. Okay. Now, I want you to go ahead and solve both of these, and I want you to come up with that final interval notation. All right, so to solve both of these equations, I can do the same thing across both inequalities. Okay, and I think I just called them equations. I meant inequalities. I need to subtract 2, okay, to get x by itself. So over here on the left, I get x is greater than or equal to 6 minus 2 gives me 4. Okay. Over here on the right, I get x is less than or equal to negative 6 minus 2 is going to give me negative 8. Okay. So if I think about what that looks like on the number line, I've got negative 8 first, then I've got a positive 4. Okay. Greater than or equal to 4 gets a closed circle. Okay. And I'm going this way on my number line. Less than or equal to negative 8. Again, I get a closed circle, and I'm going this way on my number line. So my final answer in interval notation would be negative infinity to negative 8 bracket. Again, this portion I get a union because I've got a jump. Bracket 4 to infinity. Okay, and that is my final answer for this one. Okay, so I want you guys to try number 6 fully on your own. Okay, so simplify this inequality, okay, then graph it on a number line, and then write your final answer in interval notation. Okay. All right, so to isolate the absolute value bars here, we just had to divide both sides by 5, so then we got greater than or equal to 3. Okay, then I could set up my 2 inequalities. So I had greater than or equal to 3, and then less than or equal to negative 3. Okay, to solve here, I could add 5 to both sides. Okay, then I got 2x by itself. So to get x by itself, I had to divide both sides by 2. Okay, so then I get x is greater than or equal to 4, and then x is less than or equal to 1. Okay, so my final answer is negative infinity to 1 union, again, because I have a gap here, 4 to infinity. Okay, so that is solving absolute value inequalities. We have 2 special cases that I want to briefly talk you through. Okay, so here we're going to follow the same process, isolate our absolute value bars. Okay, notice the absolute value of 3x minus 4 is greater than 5 minus 9 gives me negative 4. Okay, what do we know to be true, okay, about absolute value? This is always going to be a positive number. Okay, so any positive number, okay, doesn't matter what value of x we plug in here, we're going to get a positive number. Any positive number is going to be greater than 4. Okay, so this statement, okay, always positive number greater than or equal to negative 4. This will always be true. Okay, so that means we have infinitely many solutions. Okay, because again, absolute value bars means that no matter what, we are going to end up with a positive number. Okay, any positive number is going to be greater than a negative number. Hands down, period. It doesn't matter what number it is, it will be greater. Okay, so that statement will always be true no matter the value of x. So that means we have infinitely many solutions. Okay, so remember when I think infinitely many solutions, the way I can write that in interval notation is by doing negative infinity to infinity. And I am moving this up so I have room to write that. Okay, so here, infinitely many solutions again. Remember, I write that in interval notation as negative infinity to infinity. Now, over here, let me follow kind of the same process. I'm going to isolate my absolute value. Okay, when I do that, let's see, negative 5 minus 4 is going to be negative 9. I'm going to divide both sides by 3. 5x plus 6 is going to be less than negative 3. Okay, now, again, I'm going to put this in red. This is going to be a positive number, okay, less than negative 3. This is always false, okay, again, no matter what x value we have, because again, absolute value results in a positive number. Here, when we have a positive number, okay, doesn't matter what positive number it is, but it's not going to be, okay, less than -3. So the way we kind of represent that being untrue, okay, that inequality statement not holding, is we can put a vertical bar through it to represent not true, okay? So always false, so we get no solution. There's no like real fancy way that you guys need to know to write no solution in interval notation. You just write out no solution, okay? So those are my 2 special cases of absolute value inequalities, okay? Let me know if you guys have any questions about any of the stuff that we talked about in this lesson.